determine the appropriate depth for an electrical box when using 1-inch conduit for entry and exit with #4 wires, a specific calculation method is employed. This ensures compliance with electrical codes and promotes safety. The method involves the width of the box, the conduit size, and the wire gauge. The calculation assumes the box is rectangular or square, and the conduit inches are on opposite sides. Firstly, measure the internal width of the electrical box in inches. This measurement is taken from one interior side of the box to the opposite interior side, excluding any flanges, mounting brackets, or knockouts. This provides the total available space within the box horizontally. Secondly, subtract 2 inches from the previously determined width. This deduction accounts for the space occupied by the 1-inch conduit entering and exiting the box on opposing sides. Effectively, this step isolates the remaining space available for the wires themselves. Thirdly, divide the result obtained in the previous step by 2. This division yields the minimum required depth of the electrical box in inches. This depth ensures adequate space for the #4 wires to be safely and properly installed without overcrowding, which could lead to insulation damage and potential hazards. For example, consider a scenario where the internal width of the electrical box is measured to be 4 inches. Following the steps, firstly, we have a box width of 4 inches. Secondly, subtracting 2 inches for the conduit entries, 4 inches minus 2 inches equals 2 inches. Thirdly, dividing the result by 2, 2 inches divided by 2 equals 1 inch. Therefore, in this instance, a box depth of 1 inch would be the minimum acceptable depth to accommodate the #4 wires and the specified conduit configuration. It is crucial to adhere to these calculations to maintain electrical safety and code compliance. Remember that this calculation provides a minimum depth. Depending on the specific wiring configuration within the box, including the number of conductors, splices, and devices, a deeper box may be necessary to meet the National Electrical Code or NEC requirements for box fill. Always consult the NEC and local electrical codes for specific requirements and regulations regarding box sizing and wire fill. Additionally, always consider the manufacturer's specifications for the electrical box being used, as they may provide additional guidance on appropriate applications and limitations. For more complex wiring scenarios, it may be beneficial to consult with a qualified electrician to ensure proper installation and compliance with all applicable codes and regulations. Using the wrong size electrical box can lead to several problems, including difficulty making connections, damage to wire insulation due to overcrowding, and potential overheating, which can create a fire hazard. Therefore, accurately calculating the required box depth is a critical step in any electrical installation. This approach also ensures that the electrical work is performed safely and professionally. Always to energize the circuit before working on any electrical components. Wear appropriate personal protective equipment, including safety glasses and gloves. If you are unsure about any aspect of the electrical work, consult a qualified electrician. Improper electrical work can be dangerous and may violate local electrical codes. In addition to calculating the depth, other factors contribute to selecting the appropriate electrical box. These factors include the number and size of conductors entering the box, the presence of any devices such as switches or receptacles, and the type of wiring method being used, such as conduit or cable. The NEC provides specific guidelines for calculating box fill, which takes into account all of these factors. Box fill calculations involve determining the total volume of conductors, devices, and fittings within the box and comparing it to the maximum allowable volume for the box size. The NEC specifies the volume of each conductor and device based on its size and type. For example, each #4 conductor requires a certain volume of space within the box. Similarly, devices such as switches and receptacles also contribute to the overall box fill. By adding up the volumes of all the components within the box, you can determine whether the box is adequately sized. If the total volume exceeds the maximum allowable volume for the box, a larger box is required. In addition to the volume of conductors and devices, the NEC also considers the volume of any fittings, such as cable clamps or conduit connectors. These fittings also take up space within the box and must be included in the box fill calculation. The NEC provides tables and formulas for calculating box fill based on the number and size of conductors, devices, and fittings. These tables and formulas can be found in Article 314 of the NEC. When performing box fill calculations, it is important to use the correct values for each component and to follow the NEC guidelines carefully. Incorrect calculations can lead to improperly sized boxes, which can create safety hazards and violate electrical codes. In addition to box fill, the NEC also specifies requirements for the spacing of conductors within the box. Conductors must be arranged in a way that allows for proper heat dissipation and prevents overcrowding. Overcrowding can lead to overheating and insulation damage, which can create a fire hazard. The NEC provides guidelines for conductor spacing in Article 312.6. These guidelines specify the minimum distance between conductors and between conductors and the box walls. When installing conductors in an electrical box, it is important to follow these guidelines to ensure proper spacing and prevent overheating. The NEC also provides requirements for the support of conductors within the box. Conductors must be supported in a way that prevents them from being pulled or damaged. The NEC specifies different methods for supporting conductors based on the type of wiring method being used. For example, conductors in conduit must be supported by conduit straps or hangers. Conductors in cable must be supported by cable clamps or staples. When installing conductors in an electrical box, it is important to use the appropriate support methods to prevent damage and ensure that the conductors remain securely in place. In addition to the NEC, local electrical codes may also have requirements for box sizing and wire fill. It is important to consult with your local building department to determine the specific requirements in your area. Local codes may be more stringent than the NEC in some cases. By following the NEC and local electrical codes, you can ensure that your electrical installations are safe and compliant. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are unsure about any aspect of the work. The information provided here is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Selecting the appropriate electrical box also involves considering the environment in which the box will be installed. For example, if the box will be installed in a damp or wet location, it must be rated for that environment. Wet location boxes are designed to prevent water from entering the box and damaging the electrical components. Similarly, if the box will be installed in a hazardous location, such as a chemical plant or a grain elevator, it must be rated for that environment. Hazardous location boxes are designed to prevent explosions and fires. The NEC provides specific requirements for electrical boxes installed in different environments. These requirements can be found in Article 314 of the NEC. When selecting an electrical box, it is important to consider the environment in which it will be installed and to choose a box that is rated for that environment. In addition to the environment, the type of wiring method being used also affects the selection of an electrical box. For example, if you are using conduit, you will need a box that is designed to accommodate conduit connections. Similarly, if you are using cable, you will need a box that is designed to accommodate cable clamps. The NEC provides specific requirements for electrical boxes used with different wiring methods. These requirements can be found in Article 314 of the NEC. When selecting an electrical box, it is important to consider the type of wiring method being used and to choose a box that is compatible with that wiring method. The material of the electrical box is another factor to consider. Electrical boxes are typically made of metal or plastic. Metal boxes are more durable and can provide better protection against physical damage. However, metal boxes can also be more expensive and may require grounding. Plastic boxes are less expensive and do not require grounding. However, plastic boxes are not as durable as metal boxes and may not be suitable for all applications. The NEC provides specific requirements for the use of metal and plastic boxes. These requirements can be found in Article 314 of the NEC. When selecting an electrical box, it is important to consider the material of the box and to choose a material that is appropriate for the application. The shape of the electrical box is also a factor to consider. Electrical boxes are available in a variety of shapes, including square, rectangular, and round. The shape of the box should be chosen based on the specific application and the available space. Square boxes are typically used for general-purpose applications. Rectangular boxes are typically used for switches and receptacles. Round boxes are typically used for lighting fixtures. The NEC does not specify any particular requirements for the shape of electrical boxes. However, it is important to choose a shape that is appropriate for the application and that provides adequate space for the conductors and devices. The size of the knockouts in the electrical box is another factor to consider. Knockouts are the holes in the box that are used to run wires and cables into the box. The size of the knockout should be chosen based on the size of the wires and cables that will be entering the box. The NEC provides specific requirements for the size of knockouts. These requirements can be found in Article 314 of the NEC. When selecting an electrical box, it is important to consider the size of the knockouts and to choose knockouts that are appropriate for the wires and cables that will be entering the box. The mounting method for the electrical box is another factor to consider. Electrical boxes can be mounted in a variety of ways, including surface mounting, flush mounting, and recess mounting. The mounting method should be chosen based on the specific application and the available space. Surface mounting is the simplest mounting method and is typically used for general-purpose applications. Flush mounting is used when the box needs to be mounted flush with the wall or ceiling. Recess mounting is used when the box needs to be concealed within the wall or ceiling. The NEC provides specific requirements for the mounting of electrical boxes. These requirements can be found in Article 314 of the NEC. When selecting an electrical box, it is important to consider the mounting method and to choose a mounting method that is appropriate for the application. Finally, it is important to choose an electrical box that is listed by a recognized testing laboratory, such as Underwriters Laboratories or ETL. Listed boxes have been tested and certified to meet safety standards. The NEC requires that all electrical boxes be listed. When selecting an electrical box, look for the listing mark of a recognized testing laboratory. This will ensure that the box has been tested and certified to meet safety standards. In summary, when selecting an electrical box, consider the following factors. Firstly, the environment in which the box will be installed. Secondly, the type of wiring method being used. Thirdly, the material of the box. Fourthly, the shape of the box. Fifthly, the size of the knockouts. Sixthly, the mounting method. And seventhly, the listing of the box. By considering these factors, you can choose an electrical box that is appropriate for the application and that meets all applicable safety standards.